Hello everyone, this is Suresh. So welcome to another Google Cloud Skill Boost session. So in this session we will see the lab, which the lab is about how to mitigate bias with MinDiff in TensorFlow. Okay, so here, so let me start without any delay. Launch with 1 credit because this lab takes 1 credit, so I'm launching with that credit. Okay, let me open it in the new incognito mode. So in this session, you can see, let me log into the system successfully first. Okay, so task 0 is set up, and in one we have a Vertex AI workbench. We launch that, and we will see the clone the course repo in Vertex AI, and we will continue from there. So in this, I'm not going to explain the theoretical or any technical stuff. Here, what we are going to do is like we are going to follow the objectives that is provided over here. Okay, so in this we are going to explore the toxicity of test data and build and train and check the model bias, apply the MinDiff technique using TFMNR library and compare the results with the baseline and MinDiff. Okay, so as you might have seen, task 0 is just completed. So let me enable the APIs. So in the navigation menu, uh, I don't see app and API services. Okay, here it is. App and API services library. Search for notebooks API. And I'm enabling it. Okay, so that is enabled. Next, in the Google Cloud Console navigation menu, click on Vertex AI dashboard. So Vertex AI dashboard, and here select let me enable this. I'm just checking whether we have this enable all recommended APIs. Here we have enabled only 2. So let's try it out. Going back to the dashboard. Okay, let me select create prompt dashboard. So this is actually basically the all. Let's check the progress. Okay, this is completed. Now let's get started in Vertex AI dashboard navigation menu. Workbench. On the instances page, create new. Let me close the tutorial. Okay, please use the default region, and I will call this as lab workbench. So I'm leaving the central one and I'm selecting the zone as central one 1B as mentioned here, and I'll leave rest of the things as is and just click on create. So it is going to take a few minutes. The VM will be take 2 to 3 minutes to start. So let me wait for that. So in the meantime, if you want to see what the machines has been used, you can click on it and you can see the hardware specification, system, software and security systems. So enabled ideal shutdown. These are all the default uh, methods. We can see the health and monitor and logs. So this is still in provisioning state. We'll still wait for the green step 2 to get started. I'll pause the video for a few seconds. Okay, it took about 2 to 3 minutes. So let's get into the details in the lab workbench. So it took about a minute plus, and then you can see the hardware and you can see the softwares and the security checks, metadata and health. Health is also looking good, and you can see all the health status and the logs. If you want to, you can see all the logs, and the main thing what we are looking for is the status as active. Okay, now let's jump into uh, open Jupyter Lab. So in the meantime, let's check the progress as well. Okay, assessment is completed. So now let's move on to the task 2. Clone a course repo within your Vertex AI Workbench instance. I'm not sure whether we need Google Cloud Data Catalog API is not enabled. So for safer purpose, I'll just enable. Okay, coming back to here. So let me open the terminal. Here you can see a terminal. Select the terminal in the Jupyter Lab and clone the repository from it. So copy the command, select enter, and you can see ASL ML immersion has got created. Okay, now this is getting cloned. Let's wait for it to complete everything, and also it is making the installations. Okay, if you want to see, let's go and open the files needed, and you can see all the installation and the configurations has been done over here. Okay, so if you want to look into this, maybe you can copy the code to your local. Okay, so you can get it cloned and you can do some research on your own. Okay, so I'll wait until this whole installation to get completed. Okay, so whole installation, everything is get completed. So let's navigate, let's check the progress if we want. So in the meantime, let's navigate to this location, ASL ML immersion. This is where we are, immersion and notebooks. inside the notebooks responsible AI and folder named fairness solutions. So let me open this code. Okay, so in step 2, clear all, sorry, edit, clear all outputs. Okay, so from here, I'm not going to explain a step-by-step method here. I wanted you guys to pause the video over here and then understand the code. Okay, so my complete intention is not to explain the code line by line. It is to execute the cases, that is how it is performed here. Okay, and just to give the high level information about it. So let's continue with this, and let's to execute the code, shift enter. So no issues. And here we are taking the model MinDiff. So here you can see TensorFlow model TFMR MinDiff as MD. Okay, so these are all the necessary packages that is needed. So I'm just trying to import everything. So you can see if this is busy, so we know we cannot move on to the next step. So in this step, we'll prepare the data set. So train, validate, data train, data validate. So let's move on. So it's getting downloaded. So you can see validate, TF processed. Okay. So let's see that data train. So data train is one of the okay. Here we can see high level about it. So most of the things are 0, whereas the human is psychiatric or mental illness. Okay. So let's see in data train toxicity. Okay, equals to 1, and we'll see top 5. Now you can see toxicity is 0 everywhere, but we'll see where is the toxicity in the data train model. Sorry, data frame. Okay, and also we'll plot an histogram. Okay, now here if you see, understand the image, you can see it looks like the positive. So positive is 1, data is much fewer than the negative, non-toxic, so that is 0. So text feature equal to comment text, label toxicity, batch size is 25. So changing from pandas data frame to TensorFlow.data. Okay, so let's move on. And now we are calling the make data set, and basically we are going to convert everything into the TensorFlow data. So changing everything. So and then define and train baseline. So here we know this is the hub URL, and the Keras sequential is the model, and Keras hub and the input shape and output shape we are defining. And the layers, basically this is having 2 layers. So layer 0, I think there are 2 layers, layer 0 and layer 1. So one is with the activation Relo, second one is the activation sigmoid. So these are all the things, activation methods we will follow. So let's build the model now. So this is the baseline model we are trying to build. You can see the last line called baseline underscore model, and that is the model it is going to build. So baseline model is built. Now we will use optimizer, Adam optimizer, and the loss as binary cross entropy, binary cross entropy. Actually, this E should be in capital letters, but okay. And we are seeing the loss in metrics of accuracy, and we are baselining to fit the lost in the epochs. Basically, we are doing only one epoch. You can see it here, only single one. So let it build, and in the meantime, right, I want you guys to pause the video and understand this whole scenario and understand what we are trying to do in this progress. Okay, like in the meantime, let me check the progress here. Yeah, the assessment is completed. Good. So now let's see the validation accuracy. So this is a validation accuracy of 92%. Okay, now let's hope this is our baseline validation. So let's use a min difference method, and you can pause the video and understand the code. So first here, let's create splits with the data frames. So again, I don't want to mention repeat again because all this everything you need to pause the video and understand, because I'm not going to explain the line by line. Okay, and next let's get into this MinDiff. So we are getting trained the data. Actually, we are not trained, we are just splitting the data into two data frames. So now we have two data frames, one with the majority and another one with the minority. So let's see the sensitivity head. Okay, and second one is the non-sensitive. Okay, here the for the non-sensitive, this religion is a Christian, and for sensitive, you can see there is a Jewish and Muslim as the sensitive data train. Okay, so this is the bias what we are trying to solve. Okay, now create MinDiff data sets into batches, and we are creating the data frames as train sensitive, train non-sensitive, valid sensitive, valid non-sensitive. Now let's visualize the same thing. Check the prediction distribution. Let's visualize it. Okay, sensitive and non-sensitive. So this gives a distribution between the splits, and the minority data set has lower confidence for the negative cases that will lead to higher false positive. This is about confusion matrix. You need to understand what is the confusion matrix and understand about what is false positive. Okay, this is again all false positive results. Okay, false positive rate. So let's get into this. Let's define this function, and let's compute the false positive rate and print the non-sensitive and sensitive information over here. Definition. Okay, now here we will change. Now you can see non-sensitive false positive rate is 6%, whereas sensitive false positive rate is 14%. We see the baseline model is performing differently on different splits. Yes, true. So this is where we are coming into picture. Now you can defining and training the MinDiff model. So you can pause the video and understand what this is, and let's get into this code. So let's now I'm building a model again, and with the MMD loss and the MinDiff model, and with the optimizer as Adam and loss as binary cross entropy, and optimizer loss for accuracy. Okay, now let's create a data set. Okay, so this is for train sensitivity ordinality. Okay, and also now let's evaluate the execute the training. So this is where the training happens. So we are going to fit. So during the fit, we are going to do the training. So it will take about 1.5 minutes. You can see it over here. So what I will do is like I will pause the video. Once this is completed, then I will come back. Okay, this training is completed. Now you can see there is there is a loss of 24% and there is an accuracy of 92%, and minimum loss is 0.005. So very minimal minimum diff loss. Okay, now let's see predict the distribution again. We see this is looking better. The reason, when you compare this image with the above, here you can see there is a non-sensitive data and the bias is too much. So but this is a better picture than the previous one. Okay, now let's compute the false positive data, and you can see now non-sensitive FPR and sensitive false positive rate is both are almost same. Okay, these are very close. Earlier when we saw this kind of message, now here you can see there is a large difference. Okay, so false rate positive. Okay, now again finally this is better. Now again finally with the threshold of 0.3 we are training the model. Okay, now you can see now the between the threshold 0.02 and the 0.03 you can see this is almost the same, almost 8. Okay, so this concludes our session, and I hope you will better understand when you pause the video and go through the steps about this exercise. Okay, so but my intention is to just to showcase how the train a model and how to face with the BIOS in the Google Cloud platform. So I just showed it. Thank you very much and have a great day. Bye.